Hello and welcome to another Redline demo. We previously did a demo on the Redline exporter where we covered kind of all of the aspects of the UI and setting up the export paths and some of the other bits and bobs around that, but we didn't actually cover any of the tasks. So we didn't go through any of the FBX tasks or the Play Blaster or the R9 Anim. We didn't cover these two UIs, the export FBX settings, the Play Blaster settings, and we didn't even mention the BindPose exporter. So there's a lot more in here that we haven't covered, and that's hopefully what we'll get through today. Might do it in one, might be 2 or 3 videos, we'll see. The other thing that we didn't mention is that we obviously did the demo with the Redline Puppet, which is obviously set up for all of these systems to just work seamlessly. That isn't always going to be the case. So what I'm going to do to start with is I'm going to back off a little bit, and we'll start with a character that our systems don't know about, and we'll go from there and how we set these things up. So let's go into that now. Okay, so what we have here is a custom rig to all intents and purposes. What I've done is I've stripped all of the tag systems, all of the metadata nodes. Our systems know nothing about this rig. It is just a mere rig at this particular point. So we need to teach it how to use it. And what we're going to do is we're going to open the rig manager up. Now, the rig manager, we already have a couple of videos about how to wire things up properly. So I'm not going to go into too much detail. What I want to do is just expose the things that the exporter is looking for so you're aware of them. Okay. So first thing we're going to do is we're going to connect it to a node. Now we have a number of nodes available. The top one is the one that we pretty much use for everything except things like props. There are very slight different behaviors exposed via the exporter because of these. And the main one is the rigid body export. That will allow for non-joint objects. All the rest will only export joints. This will allow you to export locators and transforms and whatever else that you need. Okay. So we're going to create node. Now, in the previous video when we were showing stuff with multiple characters, when you select the root tag in the exporter, the character highlights. And the only reason it highlights is because it selects this wire, CTRL main. So I'm going to select the top of our rig, which is the same node that every rig has, you know, your top end rig, whatever. Connect. And then we're going to add an export tag. So the skeleton, in fact, oops, just get rid of that. The skeleton for the output on ours is the SRC skeleton, which is that one there. God knows what that's doing. It's because I've been messing around. And we're going to give it a name, Bob. So we've selected the root of the skeleton. We're giving it a name, Bob. Now then, if we do that, you'll see we have the external rig and we have the character tag. If we now open the exporter up, lo and behold, Bob now comes in there. And if I select it, oops, if we deselect and select it, it's selecting Bob because we've wired this up. Okay, so we're already halfway there. Let's carry on. Next thing I'm going to teach you about is the meshes. Now the meshes aren't necessarily important if you haven't got blend shapes. If you're not doing a blend shapes or you're not doing BindPose outputs, it doesn't really matter if you're just using the skeleton output. But I'm going to do them anyway because I'm going to take you through a bit more granularly. You can do it 2 ways. By default, we always have the render meshes wired. That's used by other systems, so it's a good habit to get into. But the main one is this, add export mesh for base FBX. So we'll click on that. This turns green, which basically means there's one marked on the rig, so we know what we're doing. The next one, remove joints from given output. Well, yes, there are nodes in this skeleton that potentially we don't want to output. So things like ends. In fact, there's so many, I can't be bothered to scan for that. So what I'll do is we'll open up the search. Search time, what is it? How do I spell it? End, capital, end. Of type joints, search. Those are all the end joints. Click. Okay, end joints are now all removed. So if I do that, those are all the end joints selected, and now they're removed. So again, skeleton output won't take those into account. And then the one below, user-defined attrs in output. That's important. Particularly, again, if you're doing the blend shape output. So by default, the Redline FBX exporter will only output transforms. It'll only do scales and rotates. Scales, there's a checkbox in there to say take scales as well. But the idea is we're trying to keep things as simple and clean and memory efficient as we can. Now to that end, if you've got custom attributes that you also want to get through, it might be that you've bound up custom, I don't know, IK target points or values, and you've bound them to a particular joint and they're custom attributes. What you need to do is you need to flag it as this joint is allowed to also output custom attributes that are on it. That's quite important. And then finally what we're going to do is we're going to do TMB pose. Now, we've mentioned it before. There's a video there about how to do it. The rig manager has a huge amount of management for TMB poses. So let's just explain it. The B pose is used if we ever need to reset the skeleton back to a default position inside the exporter. we could use the skinning. We could go, okay, just go back to bind pose in the skinning. The issue with that is if it's a game engine and it's a game export, chances are you've got IK target joints, or you've got attachment joints, or you've got some random joint that's doing XYZ that isn't part of the skin cluster. So you can't always rely on that. So we rely on B and T poses. And one point to mention here is this guy is currently in a rig. Now that means that there are probably very fine rotate values coming from the spline solver. There's probably IK solve targets, you know, rotations on the roll joints, etc. Those you don't want to propagate. You want to have it so that it is where it was when it was built and skinned. So what I've done is, in a previous file, I've just got the character that's just the base character without the rig attached, and I've saved them to file. So I've basically put him in B pose, and I've gone, where are we, save, and I put him in T pose, and I've gone save. So I've got them on file, and what I'm going to do is I'm going to use those files. So I'm going to go update from file. There's the B pose that I saved, and update from file. There's the T pose I saved. Now the T pose is using a HIK. So in the export options, we have an option to include the HIK inside the FBX animation data. And that basically uses this T-pose that we've just stamped on the character, and it uses the T-pose in there to know how to set him to lock the characterization. We rebuild the HIK on the fly. That's quite important, and that's what uses the T-pose. That's it. He's set ready for output. If we open the exporter up now, like I say, he's ready to go. So let's drop some animation on him and start playing with the functions. Okay, so in this file, we've got a typical situation for a game export. The guy's going down, he's doing a roll, we've got multiple export loops in here. So we've got an animation file, but what we also want is we want a bind pose, because we haven't created the character for the engine yet. This exporter by default is all set for animation, but we also have a very specific one for bind pose output, so we're going to look at that. We've already tagged the character up, we've already put everything that we need to on him. If we open our FBX options up, reset them, they come by like this by default. We need to turn them on to activate everything, and I'm going to turn on the sorry, I'm not even going to do that. I'm going to look at this one. So there's two tags. We've got the animation output and there's a bind pose output. Bind pose is what I want to show first. These are standard FBX options that all of the FBX character outputs have got. The only one that we've got that's custom is this one here, Maya triangulation, and that was requested by a client who basically said that the FBX triangulation was I can't use the word he said, but he wanted to use the Maya one, so we've added that in. I'm going to turn that off for the time being. Save. And again, this is an animation file, so we shouldn't really be able to output the character from here because he's under control, but we can, because we can just go output bind pose. I'll call it bind pose. In fact, there's one there. Bind, save, yes. And what you'll notice is that the guy will ping back to bind pose. Come on. There we go. Ping back to bind pose. File will get output. He'll go back to his animation because we reload the temp files. In fact, while that's going on, let's just open this file up. Clean. There we go. Wait. Refresh it. There's our bind pose. We just input that. And there's our character ready for engine. So that is taken from an animation file because we've tagged everything up, because we've got the B pose. Remember we said how important the B pose was. What it's done is it's reset the skeleton using that bind pose to get him back to that position. There's the skeleton in world space. There's the models that we tagged up as export meshes. They always sit under group core models, so things are nice and clean in the hierarchies, and that's ready for engine output. Okay, so that's that one. Really useful thing to be able to do, but let's concentrate on animation now. So first things, we have, again, the granularity that we had before, where we had settings that exist in multiple UIs and how they propagate. So the first one is the settings in this FBX settings options are global. If they're not set in anything else, these will propagate to every single thing you output. And that's important because the settings will also propagate in batch mode. So when you're batching, these settings are respected, unless we have tag settings, etc. So for example, we have bind skeleton roots there. We also have bind skeleton scales there. They're called two different things. It threw me. I have to rename that. So we've got two flags that do the same thing, binding scales. If this one is on, every single thing in this scene that's exported will have the scales bound. Remember me saying that the FBX by default, we bind only the transforms and the rotates. We don't do scales. If you want to scale it, hit that button on there and that will do to everything. If you want it to be only on certain characters, you do it at the tag level, and that will only do it for this character and this character only. Now, one thing with that, let me just save that out. What I'm going to do is I'm going to do it in debug mode. Debug mode is really good. Remember me saying yesterday that debug is quite good for building paths and seeing what's going on. It's also very good for seeing what the skeleton is about to do before it gets called to the FBX output. So I'm going to turn it on and we're going to hit that. So what we've got is, there's the output skeleton. Remember me saying that scales by default are off. We turn that on to say scales should be bound, and that then means that all of the scales are bound. Incidentally, we also bind inverse scales, and that's done for a reason. If you've got rigs where you've got lots of squash and stretch and scales going on, and you're carefully managing things like the segment scale, compensate, etc., binding the scales and inverse scales actually bypasses an awful lot of pain for you, and the data generally goes out a lot better. So that's what we do there. Okay, let's delete that. So that's the bind scales. Strip motion. Strip motion is primarily aimed at things like weapons. You wouldn't really want it on a character, maybe you would, I don't know. But the idea is that from the skeleton root, let's just grab it, from the skeleton root, obviously we've got all these joints. It might be that you've got a first person weapon animation and it's a shotgun, and you're breaking the shotgun, you put the cartridges in, you snap the barrel back shut, and you're holding all of this, but you don't want the animation of the character holding it in it, you just want the barrel animation, because you'll connect you'll attach the weapon in the engine anyway. So that's what that's there for. That's basically saying strip the motion and reset back to B pose. So it will reset this root joint back to B pose on output. So this guy should sit down there doing all this funky stuff, but with absolutely nothing on his root joint. And imagine that being a gun, that would be a reload. So again, that's what that's there for. Okay, let's go off that. Blend shape handler we'll come to in a second. What we want to do is we want to go through a few more of these things. So we mentioned HIK. We've got cast HIK, which is that flag there. Now on output by default, the HIK is ignored. If I save that and we select this, remember this guy already has a HIK definition on him. Okay, we'll open our other copy of Maya up. Go in here, new file, refresh. There's our jump, import. There's the skeleton with all the data on him, but the important thing is if we come to the animation and we come to HIK, there's our HI characterization. If we go stance, that's the stance. Now the stance is from that T-pose. Remember saying the T-pose attribute is bound? That's where the stance comes from. Ignore this. This I don't understand. I never have done why the reference root is never taken into account in stance. Don't ask me. It's part of HIK. But that's animation with HIK propagated as well, which is quite useful. Okay, turn that off and save that out. Right, we've got some general FBX outputs, obviously, whether it's wipe or ZUp, that's exposed. The version by default generally is 2018 for Unreal 4 point whatever it was. FBX types, binary or ASCII, etc. The other one though is this. Now then, this exposes a whole nother level of control over this thing. So let's have a look. So this is basically a system that we put in years and years ago, and we call it the scene root management. Now the scene root management effectively will take everything in the scene and it will modify it so that it now has a new world 0 point. That's the whole purpose of it, and it's a bit of a bodge. What it does is it groups everything very carefully, resets the root of that group to a given transform, and then resets everything back after it's output the data. The first goodness of that is that we have this thing, rig locomotion compensation. Okay, so I'm going to save that on. And remember, these are game animations, so the jump starts up there and he jumps down there. Now it might, and he's also facing negative X. These might be game animations. They might all have to start on forward facing in the positive Z at world 0 so that they bolt together. That's what that flag does. That flag there is basically going to reset everything so that we compensate where the locomotion is at frame 1 of these outputs, and it will reset it using this data here. Okay, so we're going to do that, and we'll do it with, let's do it with the jump. No, actually let's do it with, what's that one? That's the roll. So let's do it with the land roll, because he's he's kind of in the right place. So remember, he's facing negative X. Okay, and what we actually want him to do is we want to face him from here, world 0, facing positive Z. So we'll do that now. I'm going to turn debugs on so you can see what's going on. So that's what's going to get output. Okay, so he's now facing positive Z. Let's just move this out of the way. He's now facing positive Z, and he's rolling around that from world 0. So frame 1, the locomotion route will be 0, 0, 0. Ignore this. Obviously this we've spun him round, so that's part of it. But the main point is that this guy is now facing where we want him to face. Okay, and that is the scene route. What you'll notice in the scene is that we now have another node. Let's get rid of HIK. We don't want that. We now have another node, which is this thing here, this yellow thing, this yellow diamond. That is our scene route. Okay. Now, this is something that you can actually have in a scene to start with. So what I'm going to do is, if you do it in debug, by the way, you need to do the restore. That will undo everything and ungroup everything, and then you can delete the scene route out of the scene. That puts us back to where we were. But what you can do is you can create a scene route. Obviously, it's got no bearing to anything in the universe, but you can actually say that, do you know what? I want my scene route to start up here, where he currently is, on this block. So let's do that. Say that, snap. So scene route is now up there. That is basically saying that the start of the world in our system is up there. It's not down at world 0, 0, 0. It's up here. Now, it was originally designed for triggering things like in-game cutscenes or trigger in-game action scenes where you had maybe 3 or 4 characters all in one room somewhere up in the middle of nowhere in the environment, and you had a trigger in the environment that kind of said push these characters here, and we wanted to be able to output animation data from that position, and that's what this is doing. If I save this in the scene, when I come back to the exporter now, what I'm going to do is we're going to go FBX off. I'm going to take that off because I'm not going to have it compensate, because I want it to respect where this guy is now. And if we output this now, what you'll find is that he will be down there, because we've said this node is the world 0 point, and obviously there's our world grid there, so it's moved everything back down, and it's compensated it for it. So again, it's a useful way of outputting data around a specific node. The transforms, by the way, that we have in here, they get applied to the node. So if you wanted him to face in a specific direction, you can put a 90 in there, and what it'll do is it'll reset it and it'll spin him at the same point. So again, really useful, really powerful way of doing stuff. I'm going to get rid of that because I don't want that by default for me. Okay, so that's the animation output. I think we've pretty much covered most of the options in there. Oh, blend shape handler, that's what we didn't do. And the joint output, I knew there was more to go. Okay, let's just reset that. So we'll restore the scene movement. We'll delete the scene route, we'll delete that. In fact, we'll delete the scene mode out of it. Okay, so we're going back to this guy, wherever he is. He's up there on a canvas. Let's change the colour of the background, it's annoying me that one there, that's better. Okay, so specific root joint, what's that do? It's for additive output. So it might be that you've got a reload and you just want the arms in the reload. In fact, let's switch over to a different file. Let's switch over to the walk file because it's probably easier to see with this one. He's moving about too far. Okay, let's refresh that. Okay, so we're back into the one we're used to. Let's take the walk, for example. Oops. Now, in the walk sequence, he's got arm swinging. Let's say we just wanted that arm swing out in the animation data. We didn't want the rest of the skeleton. We just want the arm swing because we want to be able to add that onto previous data. So what you can do is, what I have to do is open up Tag UI, and we get, in fact, we'll take that off, and we're going to go set specific root joint. Now, it gives you a hierarchy of the joints. You can do single or multiple. I'm going to go multiple, and I'm basically going to select both arms, set. These two get set. Now, if we come back into here and we do a refresh, there we go. What we're going to do is we're going to output that with this in. So basically, the scene route is now, sorry, the joints are now saying we have 2 new routes. We're bypassing all the rest of the behavior, and we're saying we've only got 2 joints in this output. And I'm going to do it with the walk. I'm going to do it in debug again because it's quicker and easier to see than it is loading FBX files up. But what you've got is you've got the skeleton in B pose, but with just those joint animations bound up, and that's what will go out to your animation files. So again, it's really useful for building custom data up. Again, The port he's in is from that bpose. So remember me saying how important it is to make sure you have a bpose. That's what it's being used for. It's being used to reset that character in that position. And I've still got the scene root active. Let me just delete the damn thing from the settings. Yes, I have. Let's turn it off. Save. Okay, so that's that one. And then finally, we've got blend shape handler. The blend shape handler is a bit more complicated. So let's load up our facial animation and take a look at that. Okay, so we've got a bit of facial animation loaded up here. And the reason I'm loading this is because obviously this girl, I should say, has a lot of blend shape data on him. And blend shapes are always one of those things that getting it out to Engine can be a bit of a pain. But again, it's all covered in the Pro Pack. So what we've got is we've got this thing here, which basically is a blend shape handler. Now then, the root joint on this character has been tagged. Remember we saying about tagging nose to accept custom joint. It's not been tagged. Hang on a second. Let's add that in. Allow custom in output. So that's allowing customs in the output. Save. And what we're going to do is we're going to turn on the blend shape handler. There are 3 different options in this. The top one really is for Unreal, the bottom one is for Unity, the middle one is kind of a bit of a legacy stuff that we did. The top one will basically take all of the blend shape data that's on this blend shape, which is obviously connected and driving this mesh. So it'll take all of those, it'll take the target names, and it'll create an attribute on the root joint named as the same as those target names and connected to the blend shape itself. So you effectively get all the animation targets as channels on your root joint. The one below it, sorry, this one here, the root, under models group, that was a bit more complicated. What that does is it generates a dummy polygon. It recreates the blend shapes on the dummy polygon and does the same connection method, but it selects the polygon for output. And that's kind of to bypass the fact that Unity doesn't by default load the joints from the joint attributes. Unreal will just pick them up. It'll just go, oh, I've got channels on my skeleton. Look at the channel name, look at the blend shape channel name, and it'll connect the two up quite happily for you. Unity doesn't. So that's what those are for. So I'm going to use that one. Save. I'm going to select that. Again, I'm doing it all in debug mode because it's just easier to show you the data. And we're going to go run. And lo and behold, on my output chest, so there's the chest joint. There's all the attributes that have been bound and been thrown onto this root joint, and they all take the animation data. So when that animation data goes out, all of your blend shapes are now triggered by this root joint, and it saves you doing an awful lot of work and having to manually wire all this stuff up. It's all done for you. It's all just managed, and that's the purpose of it. Okay, so I think we've pretty much covered all of the animation side of stuff. What I'm going to do next is we'll go through the specific root joint. I forgot to say that the root joint output is in both. So again, it's at the tag level and the loop level. So you can do the same thing. You can put it there, or you can put it here. Okay, so that's the FBX outputs. We'll cover the Playblast in the next video, I think, because we're running on a little bit. Thanks for watching. Hopefully that's useful. Again, follow the channel, grab Pro Pack, enjoy it, test it. Let us know feedback if you find any bugs. Or if you have any issues, just contact us. Thanks very much for watching. Goodbye.